Welcome, and thank you for attending the AWS and VMware webinar series. Today, we're going to discuss Innovate and Modernize on your terms. Deploy Oracle workloads on VMware Cloud on AWS. My name is Samir Kadu. I'm a Partner Solutions Architect at AWS, and joined with me is my colleague, Sudhir.
Hi, my name is Sudhir Balasubramanian. I'm a staff solution architect. I work for the Cloud Platform Business Unit in VMware, specializing in Oracle technologies.
Thank you, Sudhir. So today's agenda is we'll go over an introduction to VMware Cloud on AWS. Then we'll discuss the benefits and use cases of running Oracle workloads on VMware Cloud on AWS. Then we'll go on to deploying Oracle workloads on VMware Cloud on AWS, followed by a wrap-up. In regards to the benefits of running Oracle workloads on the VMware SDC or VMware Cloud on AWS comes down to performance, server consolidation, accelerated provisioning, workload management, high availability, and business continuity. For example, I/O is not an issue anymore. You can scale up and scale out when needed. New hardware can increase your performance as well. And then you get to utilize the hardware that's being fully utilized in your environment, in your SDC. You can maintain application isolation as needed. You can scale dynamically and right-size your infrastructure. Being able to streamline activation, deployment, and validation of servers. Also, you can avoid manual configuration errors. Being that you have zero downtime as far as maintenance, you can migrate live databases, and then also it's utilizing VMware vSphere vMotion, VMware vSphere HA, and then VMware fault tolerance that comes into play, VMware vSphere Distributed Resource Scheduler or DRS, and then without clustering or Oracle Real Application Clusters, Oracle RAC, VMware vCenter Site Recovery Manager for your business continuity, hardware reduction at failover site, and then also the comprehensive testing of DR that comes into play with Site Recovery Manager or Site Recovery for VMware Cloud on AWS. Customers are seeking an integrated and hybrid cloud approach. So one of the key things to keep in mind comes down to where customers are looking to have their on-premises environment and public cloud environment, but also have them where the on-premises environment can utilize the familiar tools and processes. You can also then leverage the existing investments, and then also being able to maintain unique hardware configurations and then have granular control over placement of your applications and data. With that being said, in the public cloud, customers want to scale faster. They want to reduce their costs. They want to establish a global footprint, and then also utilize the pay-as-you-go model. And then lastly, having access to broader range of services. When that comes down to customers move to the cloud, they're looking for ways to get the best of both worlds without buying new hardware, refactoring, or replatforming and leveraging existing investments, skill sets, and tools. As far as application and infrastructure rework, key thing to keep in mind is 60% of the costs and 90% of the time. What that means is with migration costs, 60% of it is spent on application rework. And then 90% of the migration time is spent towards application rework as well. So we're looking to minimize the costs and then minimize the time to migration as well while moving to VMware Cloud on AWS for your workloads. Some of the common challenges that we tend to see with the hybrid cloud adoption comes down to dealing with multiple virtual machine formats. Maybe you have incongruent networks as far as the networks you have on premises versus the networks that you have in VMware Cloud on AWS or in your cloud deployment. And then operational inconsistency. What you do on premises might be different than what you do in the cloud. Having to learn new skills and tools depending on what you do online in the cloud versus what you do on premises. And then also having multiple control and monitoring mechanisms versus what you do on premises versus what you do in the cloud. So we're looking to eliminate these common challenges. You don't have to deal with multiple virtual machine formats. Your VMs are retained as a VM. You no longer have incongruent networks. The networks that you have on premises, you can stretch it out into your SDC. And then operational inconsistency does not exist because the same VMware-based environment that you're utilizing on premises, you can utilize the same operational methods that you utilize in VMware Cloud on AWS. And then as far as having to learn new skill sets and tools, you can utilize the same skill set and tools that you utilize on premises with VMware Cloud on AWS. And then with regard to monitoring, the monitoring mechanisms that you use on premises, you can leverage that with VMware Cloud on AWS as well. So in theory, nothing changes from the standpoint of a user. VMware Cloud on AWS is a jointly engineered cloud service. Key things to keep in mind is where VMware SDDC is running on AWS bare metal infrastructure. This is sold, operated, and supported by VMware and its partners. You have the on-demand capacity and flexible consumption model, the full operational consistency with your on-premises SDDC, and then seamless large-scale workload portability and hybrid operations. You also have the global AWS footprint, reach, and availability over time. And then lastly, direct access to native AWS services. So you can have it where your on-premises vCenter environment can communicate with your vCenter in VMware Cloud on AWS, and then your workloads can utilize native AWS services. So as you can see in VMware Cloud on AWS, it's based off of vSphere, vSAN, and NSX. As far as on-premises versus VMware Cloud on AWS, in your on-premises environment, from the request until ready for consumption on average for an additional host takes roughly about 86 days. With VMware Cloud on AWS, from request until ready for consumption on average for an additional host takes give or take less than 10 minutes. So we're simultaneously expanding to multiple global AWS regions to make VMware Cloud on AWS available to our customers. For example, as you can see, as far as available regions where it is available today, comes down to US West Oregon, US East, Northern Virginia, in Europe in London, Europe Frankfurt, Asia Pacific Sydney, Europe Ireland, US West Northern California, US East Ohio, Asia Pacific Tokyo, GovCloud US West, Asia Pacific Singapore, in Canada, Europe Paris, South America, Sao Paulo, Asia Pacific, Seoul, Asia Pacific, Mumbai. And then second half of 2019, in Europe and Sweden, China, Hong Kong, GovCloud US East, and then Bahrain. And then also in 2020, Asia Pacific, Osaka. And then also lastly, 2020, which I did mention, Asia Pacific, Osaka, but we're looking to expand this out throughout the regions where AWS has, and then to make VMware Cloud on AWS available in those particular regions. Some of the customer-driven use cases that we tend to see come down to data center expansion, data center extension in that case. So for example, footprint expansion on demand capacity. Maybe it's virtual desktops and published applications. Maybe you want to segment out your test dev application workloads. So for example, we've seen that with multiple customers that we've displayed the logos at the bottom of the screen. You see that with Politica, Trend Micro, PHH Mortgage, Black Mountain, A to Z. So with DR, having a primary site, a secondary site, maybe you're looking to have a new DR site. Maybe you're looking to replace your existing DR site. Maybe you're looking to even complement an existing DR facility or site. And then with cloud migrations, it could be application specific. It could even be data center wide. Or even if you're going through an infrastructure refresh, maybe it makes sense to utilize VMware Cloud on AWS at that point. And then with next generation applications, again, it could be application modernization efforts that you're going through. Maybe it's new application build outs or even a hybrid application. And then also lastly, one of the other key customers that we do want to mention over here as far as the logos comes down to Stagecoach with their use cases as well. So you can see where we have a variety of customers with a variety of driven use cases where they've leveraged VMware Cloud on AWS to best fit their needs. So we'll get into data center extension. So for example, with that, where customers are using VMware Cloud on AWS for on-demand capacity expansion of IT workloads. You can run your dev test workloads for the project duration that you might have. Maybe you want to have your environment stood up for a certain period of time to test something. Maybe it comes down to seamless expansion for your end user computing seasonal workloads. Maybe it's VDI or even published application. You may have a fluctuation that you want to deal with. And then also scalable capacity for containerized workloads. So now you have that option to pretty much expand out into VMware Cloud on AWS when needed. And then with disaster recovery. So this could come down with your Oracle DR workloads, which can be scaled in storage and compute. And then even being able to use VMware Site Recovery Service for application and orchestration. Also being able to use traditional methods as well as such as Oracle Data Guard or Oracle Golden Gate, being that you can complement your existing DR with existing solutions based on VMware Site Recovery Manager or vSphere replication. And then with cloud migration, being able to migrate individual applications or set of applications. This can come down to data center-wide evacuation or even a mass migration. So you can leverage AWS MAP Migration Acceleration Program for your mass migration. Mass migration tools and partners are available as well. And then being able to migrate to the cloud in the next hardware software refresh cycle, or you want to utilize Oracle reimplementation. So with that, I'll pass it on to Sudhir.
Thanks, Samir.
Sure.
So as we've seen in the earlier slides, some of the use cases for VMware Cloud on AWS are data center extension, disaster recovery, cloud migration, next generation applications. So now let's take a look at some of the advantages of using VMware Cloud on AWS for business critical Oracle workloads. Next slide, please. So with VMware Cloud on AWS, it's an on-demand service that enables customers to run applications across vSphere-based cloud environments with access to a broad range of AWS services. So as Samir mentioned before, it's powered by VMware Cloud Foundation. It also integrates vSphere, vSAN, and NSX along with VMware vCenter management. Well, owing to the fact that the underlying VMware stack is basically the same on both on-premises and on VMware Cloud on AWS, this ensures a seamless, low-risk migration of Oracle workloads from on-premises to VMware Cloud on AWS and back, because essentially there is no VM conversions, there is no application refactoring, and hence no application downtime. There is no networking changes, provided there's an L2 VPN capability, layer 2 VPN capability between the on-premises SDDC and VMware Cloud on AWS. The migration from on-premises to VMware Cloud on AWS and back is orchestrated using a suite of well-known Oracle and vSphere native tools. For example, VMware HCX, Hybrid Cloud Extension, Enhanced vMotion, Oracle Data Guard, Oracle RMAN or Recovery Manager. Another use case is to send the database backups to VMware Cloud on AWS or even use it as a disaster recovery target. Well, last but not the least, owing to the fact that shared storage and layer 2 multicasting is offered natively on the VMware platform without using any third-party software, Oracle RAC can be easily deployed on VMware Cloud on AWS. With the offering of stretch clusters for VMware Cloud on AWS, we can now achieve 3 levels of high availability, namely site level using multi-AZ or multiple availability zones, infrastructure level simply by leveraging the VMware HA capability, and the application level HA using Oracle RAC capability. Next slide, please. So with VMware Cloud on AWS, we can provision an entire VMware SDDC within a couple of hours as compared to the days it traditionally used to take in procuring a server, racking it, stacking it, installing ESXi, and the rest of the steps. We can now add AWS EC2 bare metal servers to the cluster on demand based on the customer's need, and hence we are able to scale horizontally, effortlessly, hence meeting the business SLAs and demands. There is no more over-provisioning or complex demand forecasting, typically found in customer deployments where one had to over-provision infrastructure and resources in advance. Well, given the fact that it's time taking to get new hardware, and actually this reduces a lot of cost. VM operations are also streamlined the same way as we would traditionally do it on premises using the VMware automation tools like PowerCLI, API, or even third-party products like Puppet and Chef. Next slide, please. With VMware Cloud on AWS, with VMware Cloud on AWS, we are able to leverage the native AWS services. Say, for example, the Amazon Simple Storage Service, Amazon S3 for Oracle backups, the AWS Elastic load balancer for load balancers, AWS directory services for managed AD. So we are now able to provide modern capabilities to legacy applications and thereby make them more robust, modern, scalable, and able to meet the business demands. One also has the ability to use AWS Lambda, which is basically the serverless framework in conjunction with Oracle workloads on VMware Cloud on AWS. We can also extract data out of Oracle workloads and leverage analytic services. For example, the AWS Redshift, the Athena, the Kinesis, and the QuickSight. Next slide, please. Well, these are some of the solutions, Oracle solutions, which can be deployed on VMware Cloud on AWS. The resource pages at the end of the slide deck will basically have all of the requisite links. Next slide, please. Well, now let's take a look at migrating Oracle workloads to VMware Cloud on AWS. On a very high level, Oracle workload migration from on-premises to VMware Cloud on AWS can be achieved in one of the two ways. First way is using the VMware Hybrid Cloud Extension, aka HCX, or the second way is to use the native VMware and Oracle methods. With the first approach, VMware HCX abstracts on-premises versus cloud notions and presents capabilities to virtual machines as a continuous hybrid cloud, hence providing minimal operational overhead without requiring a retrofit of legacy infrastructure. There are four types of HCX-enabled migration. The first one is the cold migration, where it integrates with the VMware NFC, network file copy, and uses the same network path as HCX vMotion to transfer a powered off virtual machine. During a cold migration, the VM IP address and the MAC address are preserved. The cold migration, one of the requisitions are the cold migration must satisfy the vMotion requirements. The second way to do it is using the HCX bulk migration, which basically uses the host-based replication to move a live VM to and from the HCX-enabled cloud site or data centers. And to reduce the downtime, the source virtual machine remains online during the replication and is bootstrapped on the destination ESXi server after the replication completes. The third method is basically the hot migration, where HCX vMotion, which is basically the enhanced vMotion, that can transfer a live virtual machine from an HCX enabled vCenter server to a HCX enabled remote site. The vMotion transfer captures the VM active memory, the execution state, the IP address, the MAC address, and then the migration duration basically depends upon the connectivity, which is basically the bandwidth available for the HCX migration or latency between the two sites. And the fourth way of doing it is basically the HCX vMotion with vSphere replication. It's also called the HCX replication assisted vMotion. That's the new migration method that basically combines the benefit of both bulk migration and the enhanced vMotion. So essentially, the migration begins with the replication of virtual machine disk. As it is true for bulk migration, VM can be moved in parallel with the switchover configurable on a schedule. During the switchover phase, vMotion is engaged for migrating the disk delta data and the VM state. One of the current restrictions with the HCX, the four methods, they are shared VMDKs is disallowed. So for Oracle RAC, which basically uses shared VMDKs, we would have to use the native Oracle and VMware capabilities of moving the Oracle RAC workload from on-premises to the cloud and back. Next slide, please. So as we saw in the previous section, how using VMware SCX, we were able to migrate Oracle workloads from on-premises to VMware Cloud on AWS. Right. So the next migration method approach would basically be using the native VMware and the Oracle methods. So as mentioned above, we are able to rapidly and easily migrate application workloads basically because of the fact that it doesn't require any VM conversions, there is no application refactoring, and the fact that there are no networking changes. Essentially, if one has a layer 2 VPN capability between on-premises SDDC and the VMware Cloud on AWS. This is key as some of the cloud providers, they require some level of refactoring to achieve the above points, which is not the case here. So this saves the customers a lot of time, a lot of effort and man hours trying to plan migration between on-premises and the cloud. So in this section, a single instance Oracle virtual machine on-premises is successfully migrated to VMware Cloud on AWS transparently in a couple of mouse clicks. The virtual machine is running Oracle Enterprise Linux OEL 7.4 operating system with Oracle 12.2 grid infrastructure and RDBMS binaries. Oracle ASM disks are created using the Oracle 12.2 ASM filter driver, ASM FD, and then we use the multi-tenant option running a pluggable database. By following the mentioned steps on the slide, wherein we choose the migration method, we choose the resource pool, the storage, and the destination network port group, we can seamlessly and transparently migrate the single instance workload to VMware Cloud on AWS. So the link below basically has the link for the demo, and it also has the link for the blog as well. Next slide, please. So moving your Oracle database, your Oracle workloads to VMware Cloud on AWS also enables us to continue using Oracle RAC on the cloud. So this is important because simply moving your Oracle environment to AWS does not make it possible. But deploying it on VMware Cloud on AWS allows us to continue to benefit from employing this solution. So as mentioned before, Oracle RAC has the following infrastructure requirements that are not directly available in AWS, namely the shared high performance storage accessible from all nodes in the cluster and the multicast layer 2 networking. So VMware vSAN and NSX, which is deployed into the VMware SDDC cluster, it meets those requirements succinctly, which then makes it a viable option to run Oracle RAC on VMware Cloud on AWS. So this particular slide shows a setup which uses an Oracle RAC cluster for high availability, zero downtime, connection time failover. It supports a Django Python application running on a native AWS Elastic Beanstalk environment. The Django Python application layers end-to-end provisioning is fully automated with AWS Elastic Beanstalk, which creates one or more environments containing the necessary Elastic Load Balancer, the auto scaling group, the security group, and EC2 instances, each complete with all of the Python prerequisites needed to dynamically scale based on demand. So from a zip file containing the application code, a running environment can be launched with a single command. So this content was actually demonstrated in VMworld US 2017. So by leveraging the AWS Elastic Beanstalk service for the application tier and VMware Cloud on AWS for the database tier, this end-to-end architecture delivers a high performance, consistently repeatable, and straightforward deployment, basically better together. Next slide, please. So let's take a look at the example setup shown in the architecture here. So we basically have on-premises vSphere cluster. We have site A running production workloads and site B running dev, test, and disaster recovery workloads. Both site A and site B are in a hybrid link mode. Site A and site B vSphere clusters have access to dedicated storage. Site A is connected via layer 2 VPN to VMware Cloud on AWS. The VMware Cloud on AWS is essentially, it's in a stretch cluster deployment. It's a 6-node stretch cluster across 2 availability zones. So 3 servers in AZ1 and 3 servers in AZ2. Storage in VMware Cloud on AWS is provided by the HCI vSAN instance. So the current solution, it designed and deployed 3 separate environments. So Site A had a production 2-node Oracle RAC cluster, PD RAC, consisting of 2 RAC virtual machines, 01 and 02. Site A also had a production Oracle FarSync PRDFS, essentially with a virtual machine PRDFS with the same name. Site B had a 2-node disaster recovery Oracle RAC PRDDG with 2 RAC virtual machines, 01 and 02. So the Oracle RAC on premises requires the shared VMDKs to be deployed with the multi-writer attribute and being provisioned as eager zero thick as per VMware KB article 212.1181. The current restriction of the multi-writer attribute is to disallow storage vMotion. So essentially, the migration steps on a very high level would be shut down Oracle Rack, power off VM1 and VM2. On VM2, remove the shared eager zero thick VMDKs, storage vMotion VM2 to VMware Cloud on AWS. Then on VM1, we remove the multi-writer flag from eager zero thick VMDKs. We storage vMotion VM1 to VMware Cloud on AWS. The eager zero thick VMDKs are basically converted as lazy zero thick. We would then add the new eager zero thick VMDKs with the multi-writer flag, the same size as the lazy zero thick VMDKs on VM1. We would then go ahead and start VM1, use the Oracle ASM to add and drop disk. Basically, we're doing an Oracle ASM rebalance. We would then drop the old lazy zero thick VMDKs on VM2, add the new eager zero thick VMDKs with the multi-writer at the same SCSI position, and you would essentially start the Oracle Rack cluster. Next slide, please. All right. So with the VMware Cloud on AWS, ESXi hosts by default, they reside in a single availability zone, AZ, and they are protected by vSphere HA. So as mentioned before, a feature called stretch clusters for VMware Cloud on AWS that's designed to protect against an AWS AZ failure. Applications can span multiple AWS AZs within a VMware Cloud on AWS cluster. So the vSAN fault domains are configured to inform vSphere and vCenter server instances which host reside on which AZ. To increase the clarity, each fault domain is basically named after the AZ it resides within. So extended Oracle Rack, as we all know, that provides greater availability than the local Oracle Rack. Essentially, it provides site level high availability. So it provides extremely fast recovery from a site failure, and it enables all server across all sites to actively process transactions as part of a single database cluster. So running extended Oracle Rack on stretch clusters for VMware Cloud on AWS, it provides the same advantages as running traditional Oracle Rack across the data centers and sites, in addition to the AWS AZ level protection that the stretch clusters for VMware Cloud on AWS provides. So an important aspect of any Oracle Rack configuration on VMware SDDC setup, and this is not just this is not just for the traditional Oracle Rack, it also applies to the extended Oracle Rack. The aspect is to ensure that the Oracle Rack virtual machines are not scheduled on the same physical ESXi server. So the reason being, it negates the HA proposition that the VMware SDDC has to offer. That is the infrastructure level HA, which is provided by the VMware SDDC, which complements the application level HA provided by Oracle Rack. So for us, in order to achieve this, we would need to specify virtual machine anti-affinity rules for Oracle Rack VMs, which forces the Rack virtual machines to remain apart during the failover actions. So in case of an extended Oracle Rack across multiple sites or multiple AZs, best practice is to spread the Oracle Rack virtual machines across multiple sites to ensure high availability across the site, in addition to the infrastructure level availability that vSphere VMware innately provides natively out of the box, and application level HA, which Oracle Rack provides, which ensures that all Oracle Rack virtual machine does not land on the same site at the same time. So this is basically achieved using compute policies, tags, attributes, which basically allows you to attach metadata to objects in the vSphere inventory. So deploying and migrating Oracle workloads from on-premises to VMware Cloud on AWS, that has been documented in detail in a reference architecture document, which is provided in the resource page at the end of the slide deck. Next slide, please. Well, to wrap up, the VMware Cloud on AWS is essentially brings the VMware enterprise class software defined data center SDDC software to the AWS cloud. So it's powered by VMware Cloud Foundation. This service essentially integrates vSphere, vSAN, and NSX along with VMware vCenter management, and it is optimized to run on dedicated, elastic, bare metal AWS infrastructure. So one can rapidly and easily migrate application workloads by extending on-premises data centers running VMware SDDC to VMware Cloud on AWS using the vSphere vMotion technology and back with no VM conversion, no application refactoring, no application downtime, no changes to the networking, provided one has the layer 2 VPN capability between on-premises SDDC and VMware Cloud on AWS. So the above attributes are key as many cloud providers, they require some level of refactoring to achieve the above, which is not the case here. So this thereby saves a lot of time, effort, man hours trying to plan migration between on-premises and the cloud. So all Oracle workload, including Oracle RAC, extended Oracle RAC, are supported on VMware Cloud on AWS. So the next step to take advantage of this is to contact your AWS VMware representative for building a POC or a pilot for migrating your Oracle workloads to VMware Cloud on AWS. You could also send an email to aws-vmware-cloud at amazon.com. Next slide, please. Well, some key points to highlight. So simpler ways for our customers to get started with the VMware Cloud on AWS, and both have exciting promotions. Always refer to the pricing website for details of the promotion. So we have a starter single host SDDC for proof of value. This is not for production environments, and the single host will reset after 30 days. So within those 30 days, the customers can upgrade uh, to a production SDDC with no loss of work interruption. It does not come with an SLA. And while it has many of the VMware Cloud and AWS capabilities, it does not have the capabilities that depend on having more than one host. So for example, you don't get the DRS or the HA proposition, etc. So the list price for this offering is USD $7 an hour, host on demand, with a limited period 20% off promotion. This brings the effective price to 5.6 per hour per host. The other promotion is essentially a production 3-host SDDC, which comes with SLAs. There are no time limits. It has the comprehensive set of VMware Cloud on AWS capabilities. In prior releases, customer they needed to have a minimum of 4 hosts for a production cluster. Now with this release, customers can now provision a 3-node production cluster. So the list price of an on-demand production host is approximately 8.37 per host per hour. This would mean that a 3-host cluster would have a list price of $25, $25.1 per hour on demand. So we are now offering a special limited time offer where customers can purchase the 3-host cluster at a price of 2 hosts, or effective price is 16.7 for 3-host on demand cluster. And both offerings have promotions that most of the customers will be excited about. Next slide, please. So VMware Site Recovery promotion, as you might know, VMware Site Recovery is an add-on provided on top of VMware Cloud on AWS service. It's used for disaster recovery use cases. Currently, we're running a promotion where you get free VMware Site Recovery add-on up to 90 days for a maximum of 200 virtual machines. The site there, you can learn more about it, and you can also sign up for the promotion by scanning the QR code on the slide deck here. Next slide, please. Here's some of the important resources for VMware Cloud on AWS. So learn more about the service on the above 2 links. You can find a lot of information about the typical use cases, the pricing, the ecosystem, and learning resources. There's a lot of technical information in the white papers, namely the Oracle workloads and the VMware Cloud on AWS, deployment, migration, and configuration, the Oracle database performance, VMware Cloud on AWS. Also, a lot of blog articles I've attached, which basically I've written that talks about everything related to running Oracle on VMware platform. It includes articles around running Oracle on VMware platform on premises to running and migrating Oracle to VMware Cloud on AWS. You can also see tools that relates to total cost of ownership calculations for the VMware Cloud on AWS, essentially the pricing calculator, the sizer tool, the TCO. You can also check out the latest VMware Cloud on AWS roadmap. When there are some other resources that showcases how to run Oracle on VMware Cloud on AWS, there are demos. You can also follow us on Twitter, and the Twitter handle is at VMware Cloud on AWS. You can also check out our YouTube channel that showcases the videos on the VMware Cloud on AWS service overviews, feature demos, webinars, and a lot of customer success stories. Next slide, please. So essentially, it's the same. So a lot of resources as well up here. Next slide, please. So essentially, we're now on to question and answers. So Francisca, do we have any questions in the chat or the questions? So do we have any questions on the chat?
Hey, so there looks like there's a question in regards to licensing policy. What is
Sure.
Oracle licensing policy with respect to deploying Oracle RAC on VMware Cloud on AWS?
Okay. So essentially, the Oracle licensing policy is exactly the same, whether you deploy Oracle licensing on premises, be that a classic ESXi connected to a SAN or a NAS, or vSAN, or VxRack, or VxRail, or even VMware Cloud on AWS. So Oracle RAC is supported on VMware platform, and this is right up on the Oracle website. Essentially, the meta link or the mysupportedoracle.com. The meta link note is 249.212.1. So it's 249.212.1 that says even Oracle RAC is supported on VMware platform starting November 8th, 2010. So yes, Oracle RAC is supported and the licensing model is exactly the same. So if one were to use the enterprise edition licensing model on premises, it's exactly the same on premises and even the cloud with the core factor of 0.5 for Intel processors.
Great. I think another topic that came up several times as far as questions comes down to the CPU core count. How can you control it? How does that impact this? How does being able to utilize custom CPU core count benefit customers even? That might be a good topic to get into as well.
Sure, no, that's a good one. So essentially this year, and Gary, please step in here as well to comment further. So essentially this year we released a feature called the custom core count, where essentially customers can now provision lower number of servers in SDDC with the ability to have lower number of cores per server in SDDC. So for the i3 clusters, one can go with 8, 16, and 48 cores per server, and for the R5, one could go with 8, 18, and 48. So I don't know, Gary, you probably may have to correct me on the numbers here, but essentially one does not have to go with a full 48 cores per server right out of the gate. One has the ability to lower the core as per the demand. So and essentially this was done to take care of Oracle licensing. This feature was released. So the one-stop shop link that's there in one of the slide deck, that essentially has a lot of information on that as well.
Yep, sounds good. I think one quick thing to point out, so with i3, you have 2 sockets with 18 cores per socket, and then
Right.
with R5, you have 2 sockets with 48 cores per socket.
Correct. Thank you.
Sure, yeah. So it looks like there's no other questions. Was there any other topics you wanted to hit upon, Sudhir, or should we wrap it up?
So I think we pretty much covered the essential question, which is Oracle licensing, the fact that you're able to seamlessly migrate Oracle workloads, single instance, Oracle RAC from on-premises to the cloud. You have the capabilities of doing that using both VMware tools, HCX, and the Oracle native tools and VMware native tools. The fact that licensing does not change, it's still the same way as you would do it on premises. So Enterprise Edition with a core factor of zero point 0.5. The fact that you have custom core count to reduce your current Oracle licensing to what you would want it to be. And apart from that, nothing changes, really changes from an Oracle DBA perspective. So all tools of engagement, all rules of engagement are exactly the same. So all of the tools that the Oracle DBA uses, whether it's AWR, whether it's ASH, whether it's ADDM, whether it's the V dollar, whether it's X dollar, whether it's the OEM, all of the tools remain essentially the same when one migrates their workloads from on-premises to the cloud and back.
Wonderful. Thank you, Sudhir. So I guess with that, we'll wrap it up. If you have any other questions, feel free to reach out to your AWS or VMware team. And thank you. So this webinar will also be available soon on demand. For your review, you can check it out next Tuesday. We'll run a recorded second webinar on SQL migration. There's a registration link as well that's been made available in the chat. Again, thank you for your time.
Thank you.